Good evening or morning or good afternoon or good noon to everyone that will be listening or tuning in on our video today. Today we will be learning about lesson 2, number sets and the number line. So what is a number line? Well, it's a line, just numbers. And the numbers are represented by tick marks. The mark representing the 0 on the number line, so I will draw a number line for you guys. Let's say this is a number line, okay? And this is 0. This will be called the origin point. The mark representing 0 is called the origin point. This is the origin. Alright, origin point. But what about the other numbers? Well, if I'm going to the right, usually let's think of this as right hand. My right hand is probably bigger than my left hand, although that's not true. When we go to the right, it gets bigger, but when we go to the left, it gets smaller. But you're saying, so basically, negative numbers, right? It goes -1, -2, -3. -2 will be smaller than -1 because it's more to the left. So you'll get this as we go, and we can discuss that in a later video, but you'll understand right now. So positive numbers are to the right of 0. So 1, 2, 3. These will be positive numbers, and this will be -1, -2, -3. Negative numbers are to the left of the origin point, which is 0, as we discussed. 0 is the origin point, and anything to the left of the origin point is, 0. Anything left of 0 is negative. Anything to the right of 0 is positive. And these arrows you see here, these means that the line, or like the numbers that are on the line, go on forever, and they do not stop. That's what's shown by this. Okay, so we have an example here saying graph the following numbers on a number line. So first, how do we draw a number line? Okay, we're gonna think about that. So we draw a line, said here, and just put arrows on both ends. Okay, now we're gonna have to identify the origin point. The origin point, usually 0, is gonna be here. 0, the origin point. Okay, so anything to the right of 0, or the origin point, as we discussed, is positive. Anything to the left of 0, or the origin point, is negative. We learned that. So we already graphed 0, so we can take that out. Alright, so we have to graph 3. Well, we can't just graph 3 here without like identifying the tick marks. So we're gonna have to draw like tick marks. We want like the same amount of tick marks on the right side as we do on the left side. So let's just draw like 5 tick marks here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, so we have 5 tick marks here, 5 tick marks here. Now we can identify. This will be 1, this will be 2, this will be 3, this will be 4, and this will be 5. This will be -1, this will be -2, this will be -3, this will be -4, and this will be -5. Right? So now since we have identified the numbers and the tick marks, we just have to graph. Where's 3? 3 is over here, so we graph 3. Okay? And where is -4? -4 is here. We just graph -4. And where is 2? 2 is right here, and we graph 2. See, really simple, not that hard. Okay, so we have a lot of types of numbers. We're going to discuss types of numbers in this video. But aren't there more than just one type of number? Yeah, sure, of course. There's always more than one type of number. So what are the types of numbers? Well, basically, real numbers are every single number, like fractions, decimals, like square roots, all those kinds of things. But rational numbers, they're mostly like whole numbers. They involve like negatives, integers, counting numbers, that etc. So I'm like put a like graph here so you can see that we don't need to cover like the irrational numbers yet. So we can focus on integers, okay? So what are integers? Integers, it goes from negatives to 0 to positives. These are integers, so they have all types of numbers, just no decimals or fractions, right? So it goes from all negative numbers to 0, including 0, and to all positive numbers. So then let's just say, well, what if I didn't want to include, negative numbers? Then we have whole numbers. Whole numbers include 0, but they only have positive numbers. Only 0 and positive numbers. Sorry. Only 0 and positive numbers. So 1, 0, 1, 2, 3, etc. Dot, dot, dot. Okay? So, well, let's say what if we didn't want just like no 0? Just like no 0, only like positive numbers. Then we got counting numbers, 1, 2, 3, like 1, 2, 3, 4, 5, 6. Yeah, dot, 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 right? Just keep going. So those are counting numbers. So now, since we discussed this, we're going to move on to the next example. So, okay, so we have an example here asking us to identify which numbers or which sets would these numbers be in. So, when we see -3, what do we get reminded of? So, we talked about natural numbers, or since when we were talking about natural numbers, we were talking about like counting numbers. Counting numbers are also natural numbers, okay? Natural. It's a synonym. So your teacher may refer it to as like natural or counting, but they're about the same thing, okay? So try to memorize that. So yeah, we have -3. So we talked about integers. Integers include, negatives, but do counting numbers or natural numbers do? No. Do whole numbers have negatives in them? No. So we will always have this. -3 will be in the integers. It will not be in whole numbers and it will not be in natural numbers. Put a check mark there. So, well, -3, right? Integers, well, we discussed, is a part of natural numbers. See? Rational numbers. So, we have to put a check mark on this too. Okay? And then we have 0. Are 0 in natural or counting numbers? No. Is 0 in whole numbers? Yes. Is 0 in integers? Yes. Is 0 in rational numbers? Since whole numbers and integers are in rational numbers? Yes. Okay, so we have 25 over 5 now. So we want to simplify this. What is 25 divided by 5? 5. So is 5 in that natural number? Yes. Is 5 a whole number? Yes. Is 5 an integer? Also yes. So if these are things, then rational numbers will also be that. Now we got this one, 0.8. Well, 0.80, also 0.8. Have we talked about this one yet? No. It doesn't look like a natural number, that's for sure. Does it look like a whole number? Nope. Sorry about that. Does it look like a whole number? Also no. Does it look like an integer? Nope. Doesn't really look like an integer to me. Yeah, so it doesn't look like an integer, but it is a rational number. You know why? Because rational numbers do involve decimals and fractions. So this will be a rational number. So we have -150 here. Well, natural number, no. Whole number, nope. Integers, yes. And also rational numbers. Because this is a subunit of rational numbers. Well, we have 0 over -5. Well, we gotta think about this one. 0 over -5. I'll let you give it a try. Okay, 0 over -5. What is 0 over anything? 0. So it will not be a natural number because natural or counting numbers do not involve 0. It will be a whole number because whole numbers include 0. And it will be an integer because integers include 0. And it will be a rational number because these are two our subunits of rational numbers. Now we got -1 over 3. Well, it is a fraction, but it won't be a natural number. And it won't be a whole number, and it won't be an integer since it's a fraction. But it will be a rational number because it is a fraction. See? Easy. Okay guys, that's it for today. Thank you for watching, and don't forget to subscribe. And I did that with the 5 because it's math, right? Please sub. Thank you for watching.